Alright, so minimum moves to clean the classroom. This was one of the problem from last weekly contest. We're given a M cross N grid in which we have these three or five characters S, L, R, X and dot. So let's write their meanings. S means we are starting at that position, start point. L means this is the letter, which means this needs to be cleaned, right? R means a reset, which means we have some energy, right? That we are starting with, and if we end up on this particular grid or cell, in that case the energy whatever we have at that point will be refilled to this capacity, right? And we are starting with this energy from the start point. And lastly, X and actually dot. So dot means empty cell and X means obstacle, right? So invalid cell. This can't be landed on. Okay. So what we need to find is the maximum the minimum number of moves required to collect all the items, litter items. If it's not possible, then negative one. Well, the impossible cases will be something like uh, we have actually let's take something simple. Suppose this is just a grid and we have X here, S here and L here. Right, so in that case we can't clean the classroom since we can't cross this point and answer will be negative 1, right? Now let's take a better example. Uh, what comes to our mind right off the top of our head would be to do some kind of DFS or BFS. BFS makes more sense here because of the states, right? So if we have a particular point L, then this particular cell can be traversed multiple times, right? It can be traversed multiple times. Why? Because something like, let's take another easy example. Suppose we have here as a starting point, we have L here and L here. In that case, we need to go up, we need to come back here. So we are revisiting a cell. So we can revisit a cell multiple times. And then we come here. So 3 will be our moves. So we can revisit a particular cell. But how many times can I revisit a cell, right? That is one thing that needs to be understood. So if I have something like a state, let's take the last example. Suppose we have a L here, or let me take an abstract example. Suppose L is here, S is here, we have some these are not empty cells by the way, these are just fillers. So if I am starting from here, I can reach this L point with a state of the count of the number of cleans I have already done, right? This is the count. This count will be the number that will signify how many trash or litter has been picked up by now. If from one path I am getting to this point having this count, then from another path if I am again getting to this point with this particular count, then we can see that this cell has already been visited with this particular state, right? But this is going to solve part of the problem. Reason being, I can still reach from S to here from a particular path to this point and from some other part to this point with count being same. But the strategy could be different, right? I could have picked up some other letter from this path, some other letter from this path, but our count ended up being same at this particular cell. So this still doesn't uniquely identify the path that we are taking, right? So we have to consider that two paths separately as two different paths if we are picking two different letters in those two different paths, right? So what we need is to optimally distinguish the number of L's that we are selecting, right? So this is a major point. Optimally select L uh, to distinguish two paths, right? Let's go down and see the constraint, and this will hint us towards, something, at least towards something to optimally select L to distinguish two paths, right? What we can do is, if we have a grid and we have L here, suppose here, and then here, and then here, right? So what I can do, there can be only 10 L's. What I can do is, for every path, keep track of what L I selected. But in that case, that is going to be, if I do it with a vector of int, and for every path I need a vector of int, right? That could be, that could exhaust memory, right? That will lead to something like memory limit exceed. So what we can do is, we can pre-identify a L with a ID, right? If I suppose iterate here in this way, I identify this L to have ID called 1, suppose, or suppose 0. We start from 0. I identify this L as 1, this L as 2, this L as, I'm sorry, this L has as 3. Alright, which means I have a map which is keeping track of the row and column to this ID. So if I am given a row and column which is a L, then I can use this map to identify or get to know which ID it belongs to. So I'm basically have a key value pair, and the key being row, a pair of row comma column, right? A pair of row comma column. Or I can even optimize this. This is int comma int, by the way. I'm just writing it as in a pseudo way to a ID, right? This is what we can have. And why is this going to help us? This is going to help us because since L is only 10, what I can do is, I have already identified L to have some values 1, 2, 3, 4, 5, 6, right? So what I can do is, if I'm selecting in a path a 3, that means I'm cleaning this position. In that case, I am going to bit mask the third bit of the 10 bits that I have, which means we are going to use bit masking. We are going to have at least 10 bits, right? Initially, all of them will be 0 for a particular path, right? These are not 10, are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And suppose I am selecting 2, 3, 4, 5, fifth bit, right? I am cleaning this fifth bit. That means I am going to make this a 1. We can use bit masking, and we can have this as a parameter to the number of states that we are going to add to the queue. So we are going to use BFS. We add what states? We add the mask for that particular path till that point. We add the energy level. We have to have the energy level, by the way, right, to identify if we can move forward or not. we have to have the row and column that we are moving towards, and lastly we have to have, yeah, these four things are needed. So approach is going to be BFS. There's one aspect left right now, and I'm going to discuss that after this. So BFS with four parameters: row, column, let's say mask, and this is going to be energy, right? So this is it, right? But the problem is this is going to take a time complexity of what? Row can go from till m, column can go till n, mask can go from 1 to 10, and energy can go from what? What is it? Let me see. 50, right? So this is going to be 20, 20. This is going to be what? 400. Yeah, so this is going to be the time complexity, which is what? 1, 2, 3, 4, 5. 2 into 1e5, right? 2 into 10 power 5. This interestingly leads to uh, time limit exceed. Reason being, there is one more optimization left, and that optimization is on the energy level for a particular cell, right? So if I am going to revisit a cell, this is suppose a cell, I am going to revisit from different paths, right? This different paths is going to have different masks, right? And different energies as well. So if I'm reaching this point with a energy, suppose E, from one of the path, right? Let's call this E1, and then from another path I'm reaching this point with the energy E2. Do I even need to uh, explore this path E2 if E1 is a path that is already having a larger value, right? So energy being large is better for that particular student to clean the classroom for this particular point. But the condition should be the masks should be the same. So if same mask, that means if I have chosen the same letters and I have reached this point and I have a value E1 and E2 energy level, this can be different. This is not going to be same always. This can be different because we have different placement of X, different placement for L, uh, and different paths taken, but still E1 and E2, I'm sorry, the mass can be same, but E1 and E2 might be different. One is having a larger value, one is having a smaller value. In that case, I will consider this E1 if it has a larger value and ignore this E2, right? So we need to have a, a matrix which will keep track of the best energy. This best energy, this matrix is going to be I mean, which all states are there for this particular matrix? Row and column are obvious. Masks is what we also need. Reason being, like I already told you, they has to be the same mask. In that case, if I am reaching this point with a energy value which is larger, then I am going to explore that path. Otherwise, I won't be exploring that path. correct? So let's code this up. We are going to organize our approach into steps. First step will be iterate and identify every letter with a ID. Also store it in a map. Store it in a map. Since we are already iterating, we also need to identify the starting point, that is S. So also identify start point. Next thing is do a BFS with 4 parameters. Starting point will be parameters, right? So starting point will be row column. Let's write this first. Row column mask and energy. This is going to be 0, or actually S I and S J. This is going to be the max mask. This max mask is going to be basically the point. Actually 0. It will be 0 since we are having all the bits as 0 as we start, since all the letters are as is. And the next thing is energy is also going to be 0. Not 0, but energy. Right? This is where we start with. We need to have a track best energy. Let's call this visited cell. Parameters will be row, column, and mask. This needs to be mask. Let's call this mask. The value or the size will be max mask plus 1. Right. Next thing is the value. The value for this best energy initially should be what? This is interesting. So if I am reaching a point, or if I have not reached a point, suppose this is a cell, if I have not reached this point from any path, the value of this particular cell for any mask is going to be what? Should I take 0? I shouldn't take 0. Reason being, there can be a reset point. This cell can be reached even with a energy being at this point. If we reach and the energy is 0, this is still valid because we are going to reset our energy to the maximum capacity. So this is still valid. So if we are going to use the default value as 0 for the best energy matrix, then that's going to be a problem. So -1 is a good default value, so that it's not going to affect our answer, right? So default value as -1. Next thing is straightforward. Just do a DFS and uh, check if the mask is equal to the full mask during DFS, then return the level that we are at, which is going to be equivalent to the steps, and lastly return -1 on completing DFS. Right? So let's do this. We are going to need few things. First, I'm going to have let's say direction. This direction is going to be the four directions that we need to travel to from a particular cell. So it's going to be 0 comma 1, and let me copy this 4 times. This is going to be 0 comma minus 1, this is going to be 1 comma 0, and this is going to be minus 1 comma 0. I'm going to have a classroom dot size, a variable in m, or m as that variable, and let me copy this as well. Since this is a string, I will have length here instead of size. I need a map to identify the row and column to the trash ID, right? I can have a pair of int comma int, or I can also do one thing. I can just use ing and basically get a number, unique number for every cell based on ing, right? What I mean is basically take I, multiply it with m, and plus the what it should be. Let's see, or is it I plus j plus m, right? This is it. I can just do this I plus j plus m. What I'm basically doing is taking the column and basically getting a value which is unique for every different ing, right? If I changes, then this value also changes. If j changes, this value also changes. So this always going to identify to a unique number, right? So this I can use as a key. So I don't need a map now. I can use an unordered map since I'm not using a pair. And this is going to be the ID. Let's call this trash ID. Alright, the ID initially let's have 0. I will increment it as I find L. So I am going to iterate. This is going to be J, N, J, and this is going to be basically the start point. The start point will be on a vector of int. This is the start. It's going to have initially negative value. It will be of size 2. If classroom of ij is equal to s, in that case start is going to be I comma j. Else if classroom of ij is equal to L, in that case I can just get the trash ID map. The key will be I plus M, or is it? Actually, this can also have collisions, to be honest. I'm sorry, I didn't see this coming. This can have collisions, so I can, calculate a value which is going to be unique, but just to avoid calculation and some time, I can always do pair of int comma int. This is probably a little less optimal, but still going to do the job. So what I can do is I comma j is the pair, and the id will be incremented. Before incrementing, I'll assign that value. Alright, so the next thing is I need a max mask, right? Because I'm going to use this variable a couple of times during the BFS. Also, when I'm going to create the best energy matrix, there we have the size has to be the max mask. So let's calculate this. How are we going to calculate this? The number of IDs can be at most 10, right? Or whatever the current value of ID is. It's going to indicate the number of L's, right? At this point. So this ID can be used to get the number of bits, right? If this ID is 4, then I'm going to get, suppose this ID, if I have 4 L's, then this ID value is going to be 4 at this point. This can be used to get 4 bits, right? Actually, one extra bit, because we are going to start shifting from here. This is going to be 1 shift, 2 shift, 3 shift, and 4 shift. We are going to be here. We get these 3 bits and not this. Now what I can do is I can just multiply this many times, and I'm going to get 1 shifted by 4 times. 1, 2, 3, 4. And I can do a -1, which is going to give me 1, 1, 1, 1, and this is the max mask, correct? So what I can do is, if you know bit masking, then you don't have to worry about all these small nuances. Uh, we are going to have a vector of int in the queue as a parameter. This is going to be of the format row, column, mask, and energy. This is going to be pushing, row is going to be the start 0, column is going to be start 1, mask is going to be 0, and energy is going to be energy. Alright, and I need the best energy matrix, right? Energy matrix. This is going to be a 3D vector. Let me call this visited. This is going to have M and N and mask. Mask, size will be max mask +1, comma -1 as the default value, right? So visited of the start point, the column, and the mask, that is 0, is going to be having a value. This is initially that we are starting here. We are at this point row and column. So for this particular cell, the visited matrix is going to be have value as energy for this particular point, right? Q dot empty while it is not true. I'm going to go level by level so that I don't need to keep track of the operations done as well. So while size minus minus, I am going to pop the things, the row. This is going to be 0. This is going to be 1, 2, 3. This is going to be column, mask, and lastly current energy, right? This current energy is going to be current energy. So here I am going to pop from the queue and just check if the mask is equal to the max mask. If that is the case, then return the level that we are at. So we are going to have a level which is initially 0, and I'll do a level return here. At this point, I'm going to, for every level that I'm changing, I'm going to increment the level as well, right? So here we are good to go through all the directions, right? From the directions map that we have already defined, I can just take this inside, by the way. At this point, I'll get the new row, which will be row plus d of 0, and the new column. Also, let's have the new energy. At this point will be current energy minus 1, right? And lastly, I'm going to only continue if this new row, new column is valid. So if it is valid, let's have a function for this. Let's pass the new row, new column. I need to keep check against the new row, new column. Let's have a lambda function here, somewhere here. Let's have is valid. This is going to take the outer value, so let's have the reference here. This is going to take LHS and RHS, and this is going to check, or actually let's have the row and just have row and column, and just check if row is greater than equal to 0, row is less than m, column is greater than equal to 0, column is less than n. We have m and n access since we have the reference here, and I think this is good. This is good, so we can have is valid here. If it is valid and the classroom at this particular cell is not an obstacle, that is if it's not equal to x, then we can continue. At this point it's safe to get the new mask. Let me initially have the new mask as the mask currently that we have already, right? This will handle the scenarios where the new cell that we are at, that is new column, new row, new column, is not having any L as the value, right? So at this point the new mask is going to be the mask at this point. But now we are going to check if the classroom new row, new column is equal to L, then the mask needs to be changed, right? But for that mask, or actually for this new row, new column, I need to get the ID, because that ID is going to be the bit number. So I'll get the ID from this trash ID map using this pair new row, new column. At this point, I'm going to check this bit position ID. Is this bit position inside the mask a 1 or a 0, right? Bit position ID in mask, is it a 0, which means already chosen, or 1, right? Vice versa. So if it is already chosen, then we are not going to choose it again, right? That means actually we don't even need a if condition here. Regardless if it is chosen or not, we can always convert this to a 1, right? Bit ID position in mask needs to be converted to 1 regardless of its original value. bit value. So in order to flip the bit, the new mask will be having a value mask with a OR to that bit value, right? That means 1 multiplied or shifted ID times towards the left, and with a OR we get the correct value. Alright, so now we are done with this particular check. Now this is going to be the energy check, which is going to be basically if the visited, that is the base energy matrix, if at new row new column and new mask is having a value that is lesser than the new energy value, that means this path, this point, this point can be explored. So this point shifted towards new row new column, from this cell to this cell, I can safely explore this path because the new energy value is having a larger value. I mean, it is larger than the already visited value. So I'm going to visit this, and by that I mean sorry, new mask, and by that I mean new energy is going to be the value now. I just need to check if I need to reset the energy or not. That I can check using probably new energy value can be based on this value. If it is a R, then I'm going to have energy as the capacity that is already provided. This is going to be the new capacity, otherwise it's still going to stay as new energy, right? Now I can push this particular cell with the new row, new column, new mask and new energy. Alright, so we are good. I think let's return -1 at the end. Let's see if this works. Okay, the classroom is going to be classroom, and let's see now. Oh my bad, I did one small mistake. This should be new, I mean this should be column, not new column or row, and this is good. Let's see now. Alright, this works. Let's submit this. Yeah, this works. And yeah, that's the third problem, I guess. Thanks.